All right, we are in objective 8 of our 3.1, basically writing and graphing equations. So this is, we've looked at graphing with intercepts. So we found an x-intercept, a y-intercept, we plotted those 2 points and we connected. Not all graphs are linear, where we can just plot with 2 intercepts. So this concept, graphing, making a table with multiple points to help us see the shape of a graph, is also really important. How many of you have done where you make a table of x and y values? Is that familiar? Okay, a few of you have. Some of you haven't, which is fine. Those of you who have done this before, I might be requiring of you a little bit differently. And for this lesson, for the free response and for the free response quiz, I'm going to ask you to do it this way because we're just trying to build out a foundational concept. And then once we move on past this, then you're welcome to do the shorter version that you might be familiar with. And the IXL is the slightly shorter version too. So that's okay. So the idea is, just like we could represent a function or an equation in different ways. We could look at it as a mapping. We could see a list of ordered points. We could look at it as a table. The idea is we're going to be given an equation or function, and we're going to choose some x values and plug those as literal inputs into the function, use order of operations to then find the outputs, the y values, and that's going to give us basically a set of ordered pairs that we can plot on the graph and connect multiple values then to verify that we actually have a linear function and not just 2 points. So if I had 2 points, I don't necessarily know that those represent a straight line. The more points I have, the more likely that I'm actually seeing a straight line. So I do want more than just 2 points. When we do this, typically we want to choose at least 5 x values, and a good set of x values will typically have at least 2 negatives, 0, and at least 2 positives. And then a good strategy, if your coefficient of x, so you'll see in this case, my coefficient of x is a fraction, is if we have a fraction and we chose an x value like 1, then when we multiply that x value times a fraction, we're going to get fractional or decimal values, and those get really hard to graph on a little ordered plane, and that can cause some errors, especially later when we try to solve things with graphs. So a way to get around that is to choose multiples of the denominator for our x values, so that when I multiply times the fraction, the multiple cancels and leaves me whole numbers. So looking at this example, we're going to pause here and actually apply this to our example. Looking at this example, I like to start right here at the middle with my 0. That's my first x value that I want to choose, 0, and I just stick that in the middle, and then I put some negatives above it and some positives below it. Okay, and here I do have a fractional value of x. What is the denominator of this fraction?
2.
Okay, since my denominator is 2, I want to choose multiples of 2. And the easiest multiple of 2 is 2. Well, the first one's 2. 2 is a multiple of 2. It's 2 times 1. So we'll go in the positive direction first, and we usually go down for positive. 2, 0, 2. Okay, what multiple of 2 comes after 2?
4.
0, 2, 4. Okay. And then for the negatives, we just go in the opposite direction, negative. So 0,
Negative 2.
negative 2,
Negative 4.
negative 4. And that's a good typical set, standard set of values to choose for this function. Okay. So when we choose good x values and we choose them in a consistent spacing like that and in a consistent order like that, it sets us up to recognize some patterns that could save us work also later on. So there are some extra value to choosing these standard numbers. Kai, would you mind hitting the lights over there, and that might make the board a little easier to make out? Yes, please. We'll go ahead and do both. we go. All right. So we've chosen our x values. Then we're going to go on to step number 3, which is to evaluate the function. Here's my function in the middle. That's my equation, my function, for each x value in order to find the y value. So what I recommend for the free response, this is what I'm looking for a free response until we finish this 3.1 lesson, okay, is create a frame. This is 1/2, and that's the slash form because Google Docs, which I put my notes in, doesn't let me do a vertical fraction. It's annoying. We should do vertical fractions in math. And then x, I'm going to put parentheses because to evaluate means to find the value when I replace x with the number. So parentheses is where I'll replace it, plus 4. This is the frame for that function that I want to evaluate for each x value. And I'm just going to replace that, or copy that frame in every place. Because every time my function is 1/2 of my x value plus 4. And then I'm going to be evaluating each of these frames for each of these x values. So I'm evaluating this frame for -4. I'm evaluating this frame for -2. I'm evaluating this frame for 0. I'm evaluating this frame for 2. I'm evaluating this frame for 4. Now you are welcome to use your calculator for this, but especially when we're dealing with 1/2, halving is a fairly intuitive concept, right? So I can start with my first one and say, well, what is half of -4? -2, okay? And then I have -2 plus 4, -2. All right, so my first y value is -2.
I mean 2.
Sorry, +2. Yeah, sorry, +2. +2. All right, then I have half of -2. -1.
Yeah.
-1 plus 4 is 3. What is half of 0?
2.
And 0 plus 4 is?
4.
Do we notice a pattern forming?
Yes.
What do we think the next number would be?
5.
So let's check. 1/2 of 2 is 1. 1 plus 4 is 5. 5. 1/2 of 4 is 2 plus 4 is
6.
Okay, so we end up with a sort of self-checking mechanism when we choose good numbers. For our input, we're going to get a nice pattern in our output. Okay. Now, for my example here, for space, I didn't include plotting these points. And we've done a lot of plotting points, but we're going to do 2 more examples where I do have the opportunity for us to plot. So we'll do one. Moving down to example 8a. I'm going to start with putting our x on the left. Our function for this one would be f of x equals -2x plus 3. And then we're finding our y. Or on the right here, I'm sorry, we're going to do this parentheses x comma y. So we'll write the ordered point on the right. So to start, what is the first value we want to put and where? 0 in the middle. Okay. Do we have any fractions in the denominator that means we want to use some multiples? No, so we don't need to do multiples. We could choose +1, +2, -1, -2. I will say, because my graph is pretty small, it wouldn't hurt to choose positive 2, positive 4, negative 2, negative 4. That would be fine here also. Does that make sense? So I'm spacing my points out across the graph a little bit. Both of those would be okay. Do you guys have a preference? Do you want to do 1 and 2, or 2 and 4, or 3 and 6? We just want to be consistent in our spacing.
2 and 4.
2 and 4. Let's go for 2 and 4. All right, so if we could do 2 and 4 in the positive direction, to give us nice patterns, we want to keep that same spacing in the negative direction. And then we'll draw out our frame, negative 2, parentheses, plus 3, negative 2, parentheses, plus 3. And we can go ahead and start our ordered points here by filling in those x values. So all we have to do is find the y and complete our ordered paired graph. Okay, and then we're going to evaluate each of these for each of these x values. We want to find this when x equals negative 4. So what is negative 2 times negative 4? Positive 8 plus 3? 11. Okay, and we'll do the same thing for negative 2. Negative 2 times negative 2?
4.
Plus 3?
7.
7. So an 11, 7. Negative 2 times 0?
0.
Plus 3.
3.
Okay, so 11, 7, 3. Anyone want to take a guess what they think the next number would be? Okay, we're thinking maybe negative 1. We're predicting. Okay, so let's try this for 2. Negative 2 times 2 is?
Negative 4.
Negative 4 plus 3?
Negative.
Negative 1. All right, our prediction was good. What would we predict the next number might be?
Negative 1.
Negative what?
Oh, wait, no, sorry, I did my math.
Negative 5. Okay. So evaluate for 4. Negative 2 times 4 is? Negative 8. Negative 8 plus 3 is? Negative 5. Our prediction was good. So we see the pattern happening in the y based on the pattern happening in the x. And we'll explore that pattern in more detail in a future lesson. So we're just noticing it now, and that's good. We'll get more in detail in it. So now we can follow through with graphing each of these ordered points. I'm going to start with this ordered point. Negative 4, that means I'm going to want to find the place that corresponds with the x value of negative 4. This one might not fit on my graph because my y value is 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it would be somewhere around here, roughly. I'm not going to lean too heavily on that because that's a bit off my graph. Try negative 2, 7, and we're going to label this negative 4, comma 11. Anyway, negative 2, 7, 1, 2, 3, 4, 5, 6. This is the 7 point. Negative 2, 7 right here. We'll label it. And then we have this 0, 3 point. This is 0, 3. Then we have a point at 2, positive 2, negative 1. So where positive 2 and negative 1 intersect. and we have a point at positive 4, 2, 3, 4, 5, negative 5. And positive 4 and negative 5 intersect. If we've done our work correctly, then we should be able to take a ruler or any other straight edge, another sheet of paper, your folder, and line it up over those points, and all of those points should line up together with our straight edge. Connect them all. If we get to this point and we're like, ooh, one of those points is off from the others, then we might double check our work here and see if maybe we made a math error, probably with finding our y value. Sign errors are common. Maybe when we were adding our integers, we missed something, okay? And it becomes a self-check for us to double check our work. And that's a self-check that we don't necessarily get with our x and y intercepts. If we missed one of our intercepts due to a sign error, there's not a lot to help us know that we made that mistake. So by having multiple points, it's easier to tell if one is significantly different from the others. In statistics, when one point is very different from the rest, it's called an outlier. It lies out from the rest of the data, okay? Another thing could be that we just graphed it wrong. So sometimes the point, especially if we choose good values for our x's and we have our pattern sticks, we make good predictions and our numbers match our predictions for our y's, we can just double check, did we plot the point incorrectly? So that's something to double check there as well. Okay, any questions on 8A? Okay, you guys want to try 8B on your own? I'm going to set up the well, let me give you a function, okay? So, x, this one's going to have a fraction. And let's really make this one a little challenging. 2/3 x plus, let's see here. We'll go minus 2. Two-thirds x minus 2. We'll start with our center x value. Why don't you choose your x values and let's check your choice of x values. What are we thinking for x values? 2 wouldn't divide by 3 evenly. 3 and 6, yeah. Okay, so I might go -6, -3, 0, 3, 6 for x values. Do not be hesitant. Do not hesitate to use your calculator if you like. I like to demonstrate up front, always reviewing those fraction operations. But when it comes down to it, I want you to always feel free to use your calculator unless you're on an IXL diagnostic or review skill. And once you get down through 3 of them, start trying to predict what you think your next y value might be. And then check, verify your prediction by doing the work.
You want us to graph it?
Let's double check our values first. Well, no, go ahead and graph it, because then if there is an error, we can practice finding that from the graph.
Okay.
All right, so to start checking our work, if we used -6 times 2/3 would give us -4, right?
Right. I can make it.
Negative,
yeah.
-6 times 2/3 is -4, minus 2 is -6.
Yeah.
Okay. -3 times 2/3 is -1. Sorry, -2.
Yeah.
Minus 2 is -4. 0 times 2/3 is 0. Minus 2 is -2. What's our prediction? What was our prediction for our next value?
0.
0, which 3 here, that would cancel. 2 minus 2 is 0.
Yeah.
And 6 gives me 2 times 2 is 4. Minus 2 is 2. All right, and then plotting these, we should get a -6. 1, 2, 3, 4, 5. -6, -6. 1, 2, 3, 4, 5, 6. Which would be here. Okay. Then -3, -4. Would be here. Does that look good?
Yeah.
Okay. 0, -2. Here. 3, 0 here. And 6, 2 right here.
Yeah.
Okay. Now we'll grab our ruler and connect those with a straight line. Oops, I'll hold my ruler still. It goes off the edges of the graph, has an arrow at each end off the graph that indicates this continues infinitely in both directions. There we go. How do you guys feel about it?
Good.
Okay. All right, then I'm going to go ahead and assign the IXL skill, and you guys can go ahead and get a start on that. Great job. And those of you who are watching for period 2, you will go ahead and start that IXL skill now as well.